Okay, in this video we're going to talk about rational or fraction exponents. So I want to try and figure out what exactly does 5 to the 1/2 power mean. Okay, let's first consider the following. What happens when you multiply 5 to the 1/2 power times itself? Well, we have a rule of exponents that says if you have the same base, what you're supposed to do is add the exponents. So this would be the same as 5 to the power 1/2 plus 1/2, and 1/2 plus 1/2 would be 1. This is the easy kind of math with fractions. Math with fractions should always be explained in terms of pizza. Half a pizza plus half a pizza is 1 whole pizza. And 5 to the 1 is the same as 5. Okay, so this number times itself spits out 5. There's another number that we know that does the same thing, mainly the square root. If you take the square root of 5 times itself, that should be the square root of 5 squared, which is the absolute value of 5, which is also 5. And so the idea here is that this number and this number look like they're doing exactly the same thing. They're doing exactly the same thing. If it looks like a duck and it smells like a duck, probably is a duck. So what's going to be our rule is that a 1/2 power is going to be the same as a square root. So any number to the 1/2 power is the same as the square root of that number. And notice we said square root. Square root is somehow importantly connected to squaring, power 2. And notice we have a 2 on the other side. So maybe if I replace square root with cube root, we would expect this 2 to instead be a 3. Square root's related to 2, cube root's related to 3. I wouldn't be surprised if somebody told me that that was true. It turns out it is true. The same is true for any exponent, any number you pick. A 1 over an exponent is an nth root. So if you think back, in video 2 it was, I believe, we talked about a power rule for radicals. How do you do an nth root of a times b? And it turned out it looked really similar to a power rule that we had, or sorry, a product rule we had for exponents. And the reason is that any radical you can write as an exponent, it just needs a fraction. So radicals are just fractions in disguise. Let me say that again. Radicals are exponents in disguise, where the exponent is a fraction. That was said correctly. Okay, we have one more thing to talk about, which is if 1 over n exponent spits out a root, what happens if it's a number over n? So instead of 1 over 2, what if it was 5 to the power 7 over 2? Not going to be actually that much more complicated. Let's see if we can figure this out together. He says together as though he isn't recording a video alone in a room. Okay, let's try it out. So 7 over 2 is the same as 7 times 1/2. And so then there's a couple of different ways I can write this, because 7 times 1/2 is also the same as 1/2 times 7. And we have a rule that says when you're supposed to multiply exponents. You're supposed to multiply exponents when you take a power of a power. So this one I can write this way, this one I can write this way. But the 1/2 power we just got done saying is the same as the square root. Okay, so moral of the story, if we have a fraction exponent, the denominator is going to be our root. The numerator is going to be a power. So denominators make you smaller, roots make you smaller. It makes sense that they're somehow connected. So our final rule here is going to be that an exponent m over n means you take an nth root and an m power, or you can do those in the other order. Okay, let's see an example. I'm not going to try this one because it's some wonky decimal. Let's try 8 to the 5/3 power. So there's two ways that I can do this according to what we just came up with. We can either take the exponent 5 and then the root 3, or we can take the root 3 and then the exponent 5. So our two options are to put the exponent on the inside or to put the root on the inside. Okay, most of the time, this is going to be your better choice. Not all the time, but most of the time this is going to be your better choice because you have smaller, simpler numbers as your middle steps. What is 8 to the 5th? I have no idea. It's some gigantic number. You need a calculator to figure out what 8 to the 5th is, or just sit there and multiply 2's forever. It's some really, really big number. On the other hand, if we look at this option, cube root of 8 is 2. 2 to the 5th is 32. No calculator? Done. So we have two options on how to complete problems. Most of the time, taking the root first is going to be the better option. The times that it wouldn't is when the root doesn't work out nicely, like if this had been a cube root of 7, it's going to be messy either way. I don't know if one way is going to be better than the other way in that case.